we want to close with the concept of the scientific method. Now, the scientific method, in general, is a process. It is not necessarily a series of steps that have to be followed, one after the other, but more of a reflexive kind of process where as we earn and learn and gather more information, we begin to start to adjust the way that we look at a particular problem. So, in general, we have observations, hypotheses, laws, theories, and woven into all of these is the concept of experimentation. Now, like I said, the scientific method is not necessarily a linear process. I know sometimes when we teach scientific method in early elementary school and even up through high school, we can kind of get into this way of thinking that it's, okay, the theory of relativity happened because one day Einstein was sitting in his office and thinking about things, and he noticed something weird, and so he began to do this, and he began to do that, and he came up with a hypothesis, and over time it became a theory, and so on. That's really not the process that is undergone. Usually what happens is we take note of something, and in the process of wanting to try to learn more about it, we try to start explaining things. And that's really what a hypothesis is. A hypothesis is an explanation of a phenomenon. It's tentative. It is not designed to be permanent. It is designed to be reflexive, flexible, changeable as new ideas, new observations, new concepts come into play. But above all, any hypothesis has to be testable. So we're looking for an explanation of events that is tentative, easily changed, easily manipulated, but ultimately testable. And that's where experimentation can come in, is that testing of a given hypothesis. How does this differ from a law? Look at what a law is supposed to do. A law is a description, not an explanation, a description. This is what happens under these circumstances when this substance is exposed to this environment. On planet Earth, the acceleration due to gravity is 9.8 meters per second squared. That fits into a larger law of gravitation, but it's a statement of fact. Hypothesis, theory, those are explanations. That is us as scientists trying to explain what is happening in our world. Laws have nothing to do with hypotheses, nothing to do with theories, in the sense that theories and hypotheses never become laws because they're trying to do two different things. What we will find is that often laws will be used as parts of a theory to help to try to build the validity of that theory. So in what I gave you to watch on Wednesday, when I was talking about Dalton's atomic theory, Dalton's atomic theory was propped up by a series of fundamental laws of science: the law of conservation, the law of constant composition, the law of multiple proportions. He used those laws as theoretical constructs to help him base his explanations. Basically said, if this is true, this might be why it is true. And so that really is the fundamental difference between hypotheses and laws and theories. And so the main difference between hypothesis and theory breadth. A theory is able to explain more and predict more than a simple hypothesis does. Theories are not necessarily constructed, built into the ground, never torn down. They can be flexible as well, but they tend to be a little bit more established. It tends to take a little bit more to kind of unseat a theory because it's been integrated into a lot more than just what a simple hypothesis does. So the scientific method is the process that scientists use to help us to explain the world around us. It is observation-based, it is experimentation-based, but it also is using those data to help us to explain what's around us and help us to adapt when new information comes around. So that's it for chapter 1. Any questions?